Hey everyone, welcome back. Ready for another deep dive?
Definitely. Always ready to explore some new scientific mysteries.
Well, today's topic is a pretty big one. The origin of Earth's water. You sent in some really interesting articles about comets and their potential role in this whole story.
Yeah, it's a fascinating question, isn't it? Where did all this water that covers over 70% of our planet come from?
Right. And for a long time, comets weren't really considered a serious contender, were they? They're kind of these icy wanderers from the outer solar system.
Yeah, they were seen as too unpredictable and, not really a major player in the grand scheme of things.
But some recent discoveries have started to challenge that view, haven't they? So let's go back way back to the beginning, billions of years ago.
Back to the early Earth, yeah.
Paint a picture for me. What was early Earth like? I mean, was it a place we even recognize today?
It would have been a completely alien world. Molten, fiery, bombarded constantly by asteroids and comets. It was a really chaotic time.
So, a giant molten sauna, not exactly a place you'd want to go for a swim. No, not at all. And the sun was much younger and hotter then, so any water that might have been present on the surface would have probably just evaporated.
Okay, so no oceans, no lakes, no rivers, nothing. So how did we go from that to the beautiful blue planet we know today?
Well, that's where things get really interesting. For a while, the leading theory was that asteroids were the main water suppliers.
Right, the asteroid theory.
Yeah. Asteroids formed closer to the sun, so they have a lower ratio of deuterium to hydrogen in their water.
Okay, deuterium, that's
It's like hydrogen, but with a little extra weight, like it's carrying a backpack.
Caught it, hydrogen with a backpack.
Exactly. And it turns out that the ratio of deuterium to regular hydrogen in Earth's oceans is pretty similar to what we find in asteroids.
So that was seen as pretty strong evidence pointing to asteroids, right? Like case closed.
For a while, it did seem like a pretty strong case. But then along comes Comet 67P, a comet from the Jupiter family.
Ah, 67P, the one the Rosetta mission visited.
Exactly. And what's intriguing is that earlier studies of Jupiter family comets had shown similar deuterium to hydrogen ratios to Earth's water.
Oh, really? So that kind of hinted that maybe comets could be a source too?
It did, yeah. But then, in 2014, Rosetta measured the deuterium to hydrogen ratio of the water on 67P up close.
Damn.
The ratio turned out to be 3 times higher than Earth's oceans.
Whoa, 3 times higher. So what happened? Was it just a bad measurement or something?
That's what a lot of scientists initially thought. It seemed like, well, maybe those earlier measurements of other comets were off for some reason.
Yeah, I can see how that would throw a wrench in the whole idea of comets being major water contributors.
It did, yeah. But then a team at NASA, led by Kathleen Mant, decided to take a closer look at the Rosetta data.
Okay, so they were like, hold on, let's not jump to conclusions just yet.
Exactly. And they used some really sophisticated techniques to analyze that data, and they made a pretty fascinating discovery.
Okay, I'm on the edge of my seat here. What did they find?
They noticed that there was a connection, a correlation between high deuterium readings and the presence of dust in the comet's coma.
The coma, that's that,
That hazy cloud of gas and dust that surrounds a comet's nucleus.
Right. So basically, the dust was messing with the measurements.
It seems like that, yeah.
Yeah.
You know, it's funny because reading those articles, that's what really struck me. It's like this one little detail, this dust, totally changes our understanding of the whole thing. It really does, doesn't it?
Yeah.
And it's all because of this thing called the deuterium stickiness factor.
Deuterium stickiness factor. Okay, that sounds kind of sticky.
It is, literally.
Hmm.
It turns out that those water molecules with deuterium, the heavy hydrogen ones, they tend to stick to dust grains more easily than regular water molecules.
So, if you're taking a measurement near the comet's surface where there's a lot of dust, you might get a reading that shows more deuterium than is actually there in the comet's water overall.
Ah? Okay, I'm starting to see how this all connects. So maybe those earlier measurements of comets were overestimating the deuterium because they were too focused on those dusty areas. But how does that all tie back to Earth's oceans?
That's the big question, right? And Mant's research suggests that maybe, just maybe, those earlier measurements of Jupiter family comets, the ones that showed similar ratios to Earth's water, might have been more accurate than we thought.
So hold on. Are we saying comets are back in the running as potential water sources for Earth? I mean, it seemed like asteroids had it nailed.
It's definitely not a simple answer anymore. This new research doesn't completely rule out asteroids. Not at all.
Right, like you said earlier, early Earth was getting hit with everything.
Exactly.
Yeah.
It's very likely that Earth's water came from a mixture of sources, a little bit of this, a little bit of that.
A cosmic cocktail. Yeah, I like that. But what Mann's research does is it puts comets back on the table as significant contributors, especially those Jupiter family comets like 67P.
So we started with this mystery of where Earth's water came from, and now we have like multiple suspects. It's like a cosmic whodunit.
And what makes it even more intriguing is that comets aren't just bringing water. They're also known to carry a variety of organic molecules.
Organic molecules, those are like the building blocks of life, right? I remember reading about that in one of the articles.
Exactly. Think of them as the ingredients in life's recipe. We're talking about things like amino acids, which are essential for building proteins, and even complex molecules like sugars and nucleotides.
Wow, okay. So if comets were contributing to Earth's oceans, they might have also been delivering some of the crucial ingredients for life to get started.
That's the incredible implication here. We're not just talking about water anymore. We're talking about the possibility that comets, these cosmic wanderers, might have played a role in seeding Earth with the very compounds that eventually led to life as we know it.
Hold on. So instead of just water, maybe comets brought a whole starter kit for life.
It's a fascinating possibility, and one that has scientists incredibly excited. This discovery opens up entirely new avenues of research. I mean, if comets contributed to the origins of life on Earth, what does that mean for the potential for life elsewhere in the universe?
That's a huge question. So where do we go from here? What are the next steps in this cosmic investigation?
Well, for one, we need to study more comets, especially those from the Jupiter family.
Makes sense.
We need to get a better understanding of their composition, their deuterium to hydrogen ratios, and the types of organic molecules they carry. And we need to refine our measurement techniques, taking into account factors like that deuterium stickiness we talked about.
So more missions like Rosetta, more close-up looks at these icy time capsules.
Exactly. Missions like Rosetta have revolutionized our understanding of comets. And with new technologies and techniques, we can learn even more. We can look for specific biosignatures, molecules that are strong indicators of past or present life.
When I first started reading these articles, I thought it was just going to be about water, but now it feels like we've stumbled onto something much bigger.
Yeah.
This whole idea that comets might be carrying the seeds of life throughout the cosmos, it's amazing.
It really is. And it just goes to show how science is constantly evolving. New discoveries challenge our assumptions and open up new possibilities. Who knows what other secrets these celestial wanderers hold?
That's what I love about these deep dives. You never know where they're going to lead. We started with a simple question about water and ended up talking about the potential for life sprinkled across the universe. And it all comes back to that one crucial detail, the dust on a comet.
It's a perfect example of how seemingly insignificant details can sometimes lead to the most profound insights.
So as we wrap up this deep dive, what's the big takeaway here? What should we remember about this whole comet water theory?
Well, first off, remember that the origin of Earth's water, it's still a puzzle with multiple pieces. It's probably not as simple as, one single source.
Right, we've got good evidence pointing to asteroids, but now this new research on comets, it adds another layer, right? Especially those Jupiter family comets like 67P.
Right. And it's not just about the water anymore, is it?
No, definitely not. We've got to think about what else those comets might have been bringing along for the ride. Like what else was in their luggage.
Exactly. The fact that comets carry organic molecules, those building blocks of life, that's a game changer.
Yeah, I was thinking about that quote from Kathleen Mant, the lead researcher on that NASA study. She said something like, "This is really exciting because it opens up the possibility that life on Earth could have started with a contribution from comets."
Right. That's powerful stuff.
It really is. It's like, wow, comets might not just be bringing water. They might be bringing the potential for life itself. And not just here, but, maybe everywhere.
And that's what's so exciting about this research. It's not just about the past, it's about the future, the possibility of life existing elsewhere in the universe, maybe even thanks to a little push from a comet.
It's amazing to think about, it all comes back to those little dusty, icy travelers.
And that's the beauty of science, isn't it? One discovery can open up a whole universe of new questions and possibilities.
So here's something to think about for all of us. If comets did play a role in kickstarting life on Earth, what other secrets might they be holding? What else might we discover as we continue to explore these fascinating objects? Thanks for joining us on another deep dive. Until next time, keep looking up and keep wondering.